Good evening, everyone. How are you all? Can you all hear me? Okay, that's good. How's everyone this week? Are you all doing well? Hey, if you just arrived, can you please make sure you capture your attendance? So how is everyone this week? Are you all doing fine? Worried? What are you worried? What are you worried about? The quiz and the final exam. Okay. Yeah, don't be worried. So as long as you study, so yeah, just make sure you study and prepare for your quiz and your exam. And I think you should be fine. Okay, so week 12 tutorial. I hope you all are doing fine. So don't be worried. As I said, just make sure you prepare and study hard. As long as you have prepared and study hard, you should be doing all right. So week 12 tutorial, which is this week, it is actually a revision tutorial. So before we get started, we want you all to complete a survey. So if you can please first complete a survey. So this is actually the link to the survey. Maybe I will type in this link on the chat. So please do spend some time to complete the survey. And make sure you provide any feedback that you can think of about the course, whether it's good or bad. Obviously, you can mention my name if you like. Of course, any feedback from you will be anonymous. And make sure you give constructive feedback. Obviously, any feedback that you think we could use to improve the course, right? If you think of the future you, what do you think the future you is going to think about the course, right? So what you think the future you might want or might need as in this course. And hopefully you can use your feedback to improve the course better, to be better in the future. So you're going to spend the first 5 minutes maybe, so to allow you to complete the survey. So if you can go to that link and complete the survey. And then we're going to go on the revision tutorial. So there is actually no no new content to cover this week. Isn't that good? So that's actually a good thing, right? So what that means is you're just going to do some revision to help you prepare your quiz and your exam as well. It is revision today. Yeah, revision of pretty much everything. So I think today there will be some revision on SQL, relational algebra, so transactions, and then query processing. Yeah, so it's actually only 4 questions today, and these questions are actually adopted from the previous tutorial as well. It's mainly to refresh your memory again on what we have previously covered, which is good in a way. There's actually no new content to cover. So it's really about helping you prepare for your quiz and your exam. Okay, so I'll give you a couple more minutes to complete the survey. If you can please try to complete the survey. Any feedback, there's no bad feedback, so any feedback you can provide, that would be good. Okay, so hopefully all of you had a chance to complete the survey. Let's do a refresher or revision on some of the previous topics. The first one here on SQL. So this is using the university schema. that you can download from Canvas, and then using pgadmin tool to connect to PostgreSQL. And then we need to then run the SQL to first create the university tables and populate them with data. So with this one, we have to write some SQL scripts using the university schema. So let's try writing some queries here. Actually, maybe I know all of you are probably very maybe focused on the quiz tonight and tomorrow. I was just thinking, or the schema can be downloaded from week 5 tutorial. The schema is actually from week 5 tutorial, so it's you go to Canvas, okay, and in week 5, you should be able to see here, week 5 university schema. So this is the SQL file that you can download and run on PostgreSQL. Yeah, certainly we can focus on week 8, 9, 10, 11 for the quiz rather than that is what I was thinking as well. Rather than going through week 5, maybe let's cover the topics that is relevant for the quiz. So let's have a look. Let's go back to the tutorial handout. Okay, so let's skip question 2. Okay, question 3 on serializability and update anomalies. So this is something from, I believe this is from week 7 or week 8. Probably from week 8. Probably from week 8. Yeah, so this is on transaction management, week 8. And this will be relevant for your quiz. Okay, so this one here is a question where we have a relation or a table. Okay, and based on this relation, we are then asked to answer what are the values returned by the select statements and the final value of the database. So what do you think will be the values returned by the select statements? So the select statements is this one here, first transaction. So we have 2 transactions running. Okay, and we have a table or relation. So the question is asking us what are the values returned by the select statements? So what do you think will be the values returned by the first select statements? So select star from offerings where lecture ID equals to 477. What are we going to get? Yeah, so both of the rows here, right? So we're going to get these 2 rows because both have lecture ID equals to 4711. Okay, that's quite straightforward. Now the second select. So select year into colon YR. So what is colon YR here? What is colon YR? Anyone tell me what colon YR is? Yeah, we're storing a year in the variable YR, correct. And what would be the value of YR in this case? 2012, right? Because we're looking for the row that has the university code equals to 5138, right? Which is the first row. Okay. And what is the final value of the database? What is the final state of? So once T1 and T2 commits, what will be the final value of the database? So at the end of this, what will be the final value of the database? So which one will change here? (2014). Which one is that? This one here. So this one will change 2014. Okay. So can someone tell me why this one will be 2014? Why not 2013? So let's have a look at the update, right? So the first update offerings that set the year equals to year +1, where lecture ID equals to 4711 and unit of study code equals to 5138. So that is essentially this first row. Okay. So that's the first row. And what we're doing, we're going to be adding this one to, we're going to be adding the year by 1, right? So we get 2013. Okay. Okay. So that's the first row. And then the second one, the second update, what do? Update the year. Again, updating this year here. What are we updating this to? The first one we're updating by 1. We get 2013. With the second one, what are we updating this to? Updating this by 2, right? Updating this by 2. So because we're updating this by 2, but we're updating, what are we updating? We're updating the variable YR. So we know from this one here, YR is 2012, right? So we're basically using this, the value of YR 2012 plus 2, right? So that gives us 2014, and we are then updating the year to 2014 in this case. So what that means, this year is going to be 2014. Okay. And what will happen next? So what happened next is T1 commits. So what that means, this 2013 is committed, right? So this one becomes permanent in the database. And what happened next? What happened next is T2 commits. T2 then updates the database again, changing it to 2014, right? So what does that mean in this case? So what that means is this one here replaces the 2013, right? So the 2014 overrides the 2013 in this case. And this is what we call, what do we call this anomaly? What do we call this anomaly? What is the term that we use to call these anomalies? Anyone remembers? Yeah, we call this loss update. That's right. Thank you. Call this loss update. It's a loss update because this 2013 gets overwritten. So this update here gets overwritten by the second update. That's why we call this loss update. Okay. Any questions so far?
I have a question about if we put update T2 after T1 commit, if it will return 2015.
You swap this the order, you mean?
I mean, if we put update T2 after T1, so it
You
will
update
return
T2
after T1 commit.
after T1 commits. What do you do?
We put the update we put T2 update after T1 commit.
All right. Okay. Yes. Then if T1 already commits, then T2, in this case, well, in this case, T2 will still be 2012, right? Well, the YR, because it's using YR. Okay. So you're saying this statement here is here, right? Is that what you're saying?
Yes.
Yeah. In this case, YR still remains 2012. It doesn't matter. This is already stored in the YR variable. So +2 is still going to override that. It doesn't matter. Even if you put it here, it's still going to override this 2013 because we are using these YR variables. So in this case, even if you put this here, it doesn't. It's not going to change the final results. Okay. What will happen if the order of the two updates are switched? So this one, so you do the T2 first and then followed by T1. Do you think it will be different if we swap the update, if we swap the order? So the question is, if we swap these two, we do a T2 update first and then followed by T1, right? That's what you're saying? Do you think the results will be different? Yeah, it will be the same result still, because this YR still, we still have 2012, right? So this will update the year 2014, and then T1, after that, we perform an update on T1. So T1 still sees year as 2012, right? Because it hasn't been committed. And then T1 commits, that becomes 2013. So that becomes permanent. And then T2 commits. So that will then override 2013. So you still get the same result. You still get 2014 in the end. Okay. Any other questions? You give examples of the other anomalies. Yeah, we can dirty rates and unrepeatable rates. Okay. So dirty rates. So dirty rates. So what would be a good example of dirty rates in this case? So dirty rates, basically you are reading data that has not been committed, right? So that's dirty rates. I wonder if the lecture slide has a good example. Let me actually have a quick look. Might be able to see a sample from the lecture slides. Is there a dirty read example from the lecture slides? Okay. So dirty read essentially is reading uncommitted data. So you're reading data that has not been committed. That's why it's called dirty reads. So what is this example here? So read A and then read A, write A and then read A. Okay.
Is that one for the unrepeatable reads? Is that one? Is the example
yeah.
for unrepeatable read? Is the first one, I think, the example.
Okay, yeah, it might be the first one, you're right. So the first one, read 1A, W, read, write A, and then read, write, and then read, write. So what does this line represent? What does this line represent? So this one is reading the value of P and writing the value of P. It is breaking before finishing T1. Okay. So we're saying here there might be a failure here. Is that what we're saying? There might be a failure in the middle. Before T1 finishes, might be a failure. Is that right? And then essentially, then what B is reading, is an alt data, or data that has not been committed. Yeah, so this one sounds like, because the data has not been committed, right? So it has not been made permanent in this case. So how can transaction 1 reads data that has not been committed? So essentially, T1 here is reading an old value of P, or new value of P, but that new value of P has not been committed. So I think this is not a good example. Yeah, there's only one example here. I don't think there's any other example. It's only one example. Yeah, so essentially what we're saying with dirty reads is we're reading data that has not been committed. That's essentially what it is. That's why it's called dirty reads, because the data actually has not been committed yet, and we're reading that data in this instance. So I think what it is saying here, we're reading B, but B actually has not been committed yet.
Why is not commit for the T2? How can we know it's not commit?
That's why this one has got the line. I think the line here probably represent, the red line here maybe represent a breaking point. I think someone said it's a breaking point, isn't it?
So it's like the T1 read uncommit data from T2.
Yeah, T1 reading data from T2 that has not been committed, essentially.
Oh, okay.
Does it make sense? So basically T2 already writes some data to B. That's what it looks like here. And then there's no commit yet, but T2 already makes an update to B. So T2 makes an update to B, but has not been committed. That's why we call it dirty, right? For dirty. And then R1 here, T1 reads B based on this update. Okay. But T2 actually has not been committed yet, has not committed yet. So this one has, there may be still more changes to be, who knows, right? but T1 doesn't know that. T1 basically simply see, okay, this is the latest B that was written by transaction 2, and that data apparently has not been committed by transaction 2. This one is called a dirty reads.
So
It's
why
not-
not the T2 read income data from T1? Like the T1 had write dataset A and the T2 read dataset A. Why not the T2 read income data from T2 read income data from T1?
T2 reads uncommitted data from T1.
Yeah, because we have read on dataset A and read dataset A from T2. Firstly, we write on dataset A, and secondly, we read dataset A on T2. So why is not?
You mean this one here, like this?
Yeah. Yeah,
Yeah,
correctly.
but the breaking point is here though. This is the breaking point. So in this instance, my understanding in this case, T1 is reading data from T2 that has not been committed. So might be reading B value here that has not been committed.
Okay, so we just say the break line. It will give us the break line.
Yeah, there's a failure here in this case. So the assumption, the break line here, the red line here is a breaking point. So there is something written already by T2, but looks like T2 has not committed. There's a failure. I think when it tries to commit, there's a failure probably.
Okay.
I think we need to understand what this red line means. It's not clear what the red line means here, unless someone pay attention to the lecture as to what the red line means.
Thank you.
But essentially, what we're saying here, dirty reads is uncommitted data, right? So any transaction reading data that has not been committed, we call that dirty reads. That's essentially what the meaning of dirty reads. And unrepeatable reads. So what is unrepeatable reads? May not read the same value twice. Okay. So we're saying here, when we first do a read of A may be 3, example, and then T2 here maybe writes A and changes that to 4. And what that means is when T1 reads A again, A already changed the value to 4. So that's what we call unrepeatable reads. Okay, so basically, depending on when you read, you may get a different value because initially T1 sees A as 3, but later on, A has been updated by T2, and therefore T1 reads the value of the latest value of A as 4. That's why we call this unrepeatable reads. You may not get the same read twice, the same value twice. And this one we know, this is update anomalies because this one overrides that, okay? So T1 write overrides T2 write. So this is loss update. Okay. Any question? Yeah, so basically my assumption here, right? This is a failure point or breaking point. The data has been updated by T2. So the B has been updated by T2, but has not committed. T2 has not committed. And then R1 here reads the new B, which is updated by T2 that has not been committed. That's why we call it dirty reads. In this case, let's say this one, 3, B is 3, and then when T2 writes to 4, but has not actually committed, and then T1 then writes B equals to 4, in this case. That's what we call dirty reads. So basically B is seeing a value that was previously written by T2, but where T2 has not committed yet. Yeah, this could come up in your quiz actually. It sounds like a good quiz, a good quiz question actually. I think your quiz, maybe if you're getting multiple choice, perhaps, you know, they may give you a few scenarios and then they may ask you, all right, is this a dirty reads? Is this unrepeatable reads? Or is this a loss update? Maybe, you know, I'm just guessing. How to differ unrepeatable reads and dirty dirty reads and unrepeatable reads. So I think dirty reads is you're reading data that has not been committed. So that's dirty reads. Whereas unrepeatable reads, if you do multiple reads, right? So I think the key word here is repeatable. When we say unrepeatable, that means you cannot repeat, right? So basically, when you do multiple reads many times, more than one time, right? You may get different values. Whereas dirty reads, it's got nothing to do with multiple reads. Dirty reads is simply you're reading data that was previously written by another transaction, but that transaction breaks. That transaction has a failure. It has not committed. That transaction has not committed, and you're actually reading data from that transaction that has failed. That's essentially what happened here. T1 reads data from T2 that has failed. That's what we call that dirty reads. Whereas unrepeatable, you're reading multiple times. You read T1 here perform multiple reads, right? First time and second one. The second time it reads again, it gets a different value. It gets 4 instead of 3. So the first time it gets 3. The second time it does a read, it gets 4 instead of 3. Yeah, the difference is really in the repeatable. You're expecting there will be multiple reads.
Yeah, I have a question about the dirty reads. It seemed like the lecture said T2 finished and the T1 rollback and the T2 read the WEA. So T2 is the dirty read.
T2 is the dirty reads.
Yeah, because the read 2A read the value of the W1A.
Oh, you mean T2 reads the T1 that has not committed? Is that what you're saying?
Yeah, because this line means T1 rollback, which means its value roll back to the default value A, and so but T2 has finished, so T2 still reads the T1's A, T1's write A,
Okay.
T1's write value.
So essentially you're saying T1 has not finished the transaction.
Yeah, because
but
T1 roll back and T1 gets the A value from the what's
so,
which instead.
let's say A starts with 3 and then written by A is 4. And then T2 reads 4, is that right?
Yeah.
Okay. And then write 5, let's say. And then you're saying there's a failure.
Yeah, the T1 rollback, they get the value, they get back a value for 3.
Okay. Yeah. Okay, yeah, that makes sense as well. That's right. So that means this failure of 4. Yeah, so that could be that is a valid case of dirty reads. So in this case, T1 rollback. So we're saying here, this red line represents T1 rollback. Okay. So T1 rollback, essentially, this write 4 has never been committed, right? This was never committed, but T2 actually reads that new value of A, which is 4, which means this value 4 is 30. Yeah. Does everyone get that? So that is a valid use case. Absolutely. T1 rollback in this case. So the red line here basically means T1 rollback. Okay. Any other questions? So that's on update anomalies. Okay, so conflict serializable. Conflict serializable. How do you determine whether it's conflict serializable or not? Want to look at question 4? Yeah, of course, we can look at question 4 as well. So calculating time and space. This one basically looks at how we need to know how many we can fit in a block, right? So what do we do with this question? So we need to know how many can we fit in a block. We also need to know what's the header size. Hopefully you all still remember. Okay. So 250 head taken by the header. So essentially what we want to fill is the remaining one with the records. So how many, we need to find out how many can we fill in a page. So this is a page. So the page has a size of 4096. Okay, so the remaining one we can fill is 4096 minus 250, right? And we should get 3846, I think, bytes. And then 3846 divided by, so if we need to find out how many records can we fill, we can, obviously, because this is ABC, then we say 4 plus 12 plus 8, right? We get 12, 4 plus 12 plus 8 is 24. So make sure in your quiz, if this comes up in your quiz, you have to show your working. You cannot just simply say the final answers. Make sure you do step by step, because it's important for us when we assess your answers. We know how you actually get to the final result. So instead of just showing the final result, you need to show your workings, right? Show step by step how you work out your answers. That's the size of a record, and then to get the how many records can we fit, so you simply divide by 24, right? Okay, and what do you get? So 3846 divided by 24, you get like 160, right? 160 records in a page. Okay, everyone gets that? And so 160 in a block or in a page in this case. And then if you want to know how many blocks do we need, just simply divide that, right? 100,000 divided by 160, we get 625, isn't it? 625. Okay. So one very important thing is to make sure that you state your occupancy rate. So this is based on 100% occupancy. Make sure you state this. So if the question does not specify, you have to make sure you specify this, because otherwise we won't know whether you're using 75% or using 100%. Yeah, so yeah, specify that you're using 100% occupancy. And then once you have this, then we can calculate the size of we can calculate how many, based on 625 pages, we can calculate the space required, right?
So it should be multiply the 4K bits, the
Yeah.
4 bit 4K.
So 625 times 4 kilobytes, we get about 2400, right? So I think it's 2500, isn't it?
2.4 MB, I think.
Yeah, which is about
2.5.
2.4 MB. So we divide this by obviously 1024, okay, which is roughly about 2.4 megabytes. Okay. Any questions on this? It's actually 2.44, but yeah, 2.4 is fine. So if you only show the final, if you only show the final answer without the workings, you probably only get partial mark. You probably only get 1 mark, maybe. Showing how you work out the answers, that's very important, because otherwise, yeah, you only get maybe very little mark, even though your final answer is correct. Because we won't be able to know whether you understand how to work out the final answer. It's important for you to show the, how you arrive at the answers. Yeah, that's fine. If you don't specify, I guess, if the question has not specified the occupancy rate, you can use 100%. You can also use 75. So either one is correct. So whether you use 75 or use 100%, as long as the question does not explicitly state that you have to use one or the other, you can use either one. Or you can just, you want to keep it simple, just stick to 100%, I guess. But with 100%, you have to make sure that you don't have any records that get split across pages. So like this one, right? If it's this one, actually 160.25, I think. Okay. Because if you're filling up to 100%, then you have to remove this. You have to remove the 0.25. Because the 0.25 we cannot split across pages in one page. So we can't have 0.25 record in one page. We just can't have that. So if you use 100%, you just have to be careful with the decimal place. Because if you say 161, for example, let's say you use 100% occupancy and then you say it's 161 here, then that's incorrect. Okay, any other questions? I guess we can continue with the next one. Okay, the next one is the linear scan. So I think this one is straightforward, right? 625 times, we basically read every single pages. So if one page takes 150 milliseconds, and if we have, depending on how many blocks we have, so if we have 625, we just simply times 625 times 150. Because in a linear scan or table scan, we have to read each block sequentially. So one block at a time. So 625 times 150 milliseconds. So 161 is incorrect because, so 161 is incorrect. The reason being, we only have 3846 that we can feed our records. And if we try to put 161, that is not sufficient. We don't have enough space to fit 161. The most we can fit is 160.25. The most we can fit in a block is 160.25. But we cannot split record in a page. we can't have 0.25 record in a page. So this 0.25 has to be removed. That's why we do a ceiling, not a ceiling, we do a floor of 160.25. That's why the answer is 160, not 161, not 161, not 160.25 either.
Should it be minus the 250? If I multiply 4 KB, should I minus the 250? Like we should
For which one?
600. This one, yeah.
625. No, because the 625 is already includes the header as well. This is 625 pages of blocks, and each block has the 250 header, right? Each block has a size of 4K already included here. Already included the 4K. So we know we need 625. Each block has has a size of 4K. So we don't need to minus 250 in this case.
Can you check on add?
Check on add.
Yeah, because there are same question, but the answer should be 3,846.
Let me see. Which one is that? So I think when we calculate the number of pages, so that's correct. You know, I mean, this is right. When we calculate the number of pages, we have already minus this. So 3846, this is already minus 250. So that's correct. That's how we get 160. And then 100,000 but divided by 160, we get 625 pages. So there's nothing wrong here. We don't need to minus this again. We don't need to minus 250 again because we already done the minus here. We already used to 3,846 divided by 24 to find out how many records we can fit in a block. Does that answer your question?
Yeah, I'm just confused why lecture gave us should minus the 250.
Yeah, I think that's wrong.
Okay, thank you.
Yeah, I think the lecturer probably has not read the question properly. It should be just 625 times 4096 times 4 kilobytes. You shouldn't have to minus 250 again, because we want to calculate the size, right? We want to calculate the size, the space required. So we know we need 625 pages or blocks, and each block has a size of 4 kilobytes. So we know this is the size of a block, including the header. So this size of 4 kilobytes does include the header. The question is asking for the space needed, right? Space for records. Yeah. Yeah, in my view, you don't need to minus 250 again. But you're right. I can see why it might cause some misunderstanding, because it might say, oh, you just want to calculate here in this case the space for the records, because that might be misleading, I guess. Okay, any other questions? I'm gonna clear this drawing. Yes, I will use 4K. Because that's the size of a page. The statistical base is 4K, so that's why we times 4K times 625. Any other questions from lecture 7? Is it 6, 7, 8, 9? Is it from 7 is really not assessed, right? Only 6, 8, 9, 10, right? I think they will be assessing your quiz. On 9, 8, 9, 10, 11, actually, that's the one. 8, 9, 10, 11. So if we answer how many pages in this question, can we get full mark? Which question? This question is asking the space, not the number of pages. So the answer for this one should be 2.4 megabytes. Okay. So you need to convert back to the size rather than the number of pages. Does that answer your question? Actually, I have just calculated, right? So if we, so we got 625 blocks, right? So if I've just calculated, if we use 4K, right, which is 96 minus 250, right? If we go with this approach, right? Let's see what we get. So 625 times 38646. Times 625, right? 750. Okay. Divided by, so we get divided by, so this is obviously in bytes, right? 1024 times 1024. What do we get? We only get 2.29 megabytes. But that's not right. Whereas the answer is 2.4 rather than 2.29. So this is the answer. Okay. So I guess hopefully that clarifies some of the concerns as to why we should use 4 kilobyte rather than 4 kilobyte minus 250. The answer is 2.4 megabytes, not 2.29 megabytes or 2.3 megabytes. Okay. Someone asking about 4.2. Okay, I think we discussed 4.2, right? So 4.2 is basically 625 times 150 milliseconds, because to perform a table scan or linear scan, we have to read the block one by one. So read all the blocks sequentially. So one block at a time. That's why we have to read all the 625 blocks. Because we have to read 625 blocks, that's why the time taken is 625 times 150. So that gives us 93750 milliseconds, which is about 93.75 seconds. So that's that. How long will we take if we use B+3 should be 150 times 625 divided by 3846 divided by 20. I'm not sure what you're trying to say there. How long will it take if we use B+3? So I'm not clear what you're trying to ask, but if you're trying to ask if we use index, is that what you're trying to say? You use index, how long?
Index key. If we use index key, and we have already set the B+3 index. So how long would it take?
Well, if you use B+3 index, it's gonna we won't need to read all the 625. We're probably only gonna need to read the root and then the second level index. Okay, remember of B+3, what it looks like, and then the third level, right? So we need to read the root, second level, and the third level. And obviously the question would be, how many do we need to read at the third level? How many record pages do we need to read? How many leaf pages or the record pages we need to read on the third level? So this is the question we need. This is the question we need to answer. How many will be on the leaf pages we need to read? But it will not be 625. It will be less than 625. So depending on what we're looking for, right? So I think it comes down to what is our query. So if we're looking for A, B, or I don't know, we're looking for if you're looking for A and B, right? For example, we need to know how many records there is. And then from that, we need, based on how many records there is, we need to find out how many blocks will fit can we fit those records? If you we're only looking for one record. If you're looking for one record only, then we only need to read one block. Which means that it's going to be 1 + 1 + 1. Only 3 pages that we need to read. Okay. With only 3 pages, 3 times 150, only for 50 milliseconds. That's why it depends on how many records we need to read at the leaf. Does that answer your questions?
Yes, I think so.
Yeah, so basically the bottom line is if we're using index, it's going to be a lot faster. It should be a lot faster. And obviously that depends on how many records we're looking for. We're searching for one record. Yes, only one block. If searching for 2 records, maybe we need to read 2 blocks. If searching for three records, maybe we need to read 2 blocks. 2 blocks as in at the leaf node. Okay. So maybe this block and this block here, perhaps. It could be 1 + 1 + 2. If we need to read 2 blocks, it becomes 1 + 1 + 2. It means it's 4 blocks we need to read. Okay. All right. I think that's pretty much it. Good luck for your quiz. And yeah, all the best. So hopefully all of you get a good marks for the quiz. You still have time to study, so yeah, use the best of your time to study. When calculating the space, we don't need to consider the index. Yeah, you don't. That's right. All right. Thank you, everyone. All the best. And do try your best, try hard. Yeah, hopefully all of you get a really good mark for your quiz. Thank you. And yeah, I'll speak to you all again next week. I think there's going to be one more revision tutorial next week. All right. I'll see you all next week.